Here we want to solve the inequality and write the solution in interval notation. So if we take a look at this, this is a rational inequality. We have x minus 5 over x plus 6, and it's greater than or equal to 0. So the first thing we need to ask ourselves is this rational inequality, does it have one term on the left-hand side? Yes, it is. And do we have 0 on the right-hand side? Yes. So therefore, now we can continue to find our critical points. Okay, so if we take a look at the numerator is x minus 5. We're going to set that equal to 0 and solve for x. If we add 5 to both sides, then x equals 5 is one of the critical points. And then we need to take a look at x plus 6. Now keep in mind that since it's in the denominator, this is a restricted value. So that means we have x plus 6, which is equal to 0. And if we solve for x, we're going to get x is equal to negative 6. But keep in mind that this is a restricted value. So the next thing that we're going to want to do is now we're going to create our number line. So here we have our number line. We have negative 6 over here, and then we have positive 5 here. And then we're going to create our regions from those critical points. So we have a region that's divided between negative 6 and also another one that goes through 5 from our critical points. And now let's take a look at our intervals. Well, on the left, we know we're going to go from negative infinity to negative 6. Now, does negative 6 have a bracket or a parenthesis? Now, if we look at the inequality, it says greater than or equal to. So it looks like we can include it, but because it's a restricted value, we can't. So we're going to have a parenthesis there at negative 6. So the interval here is negative infinity to negative 6. And then we're going to have a parenthesis at negative 6, and then we're going to go to 5. Now 5, it can be 0, and it's not a restricted value, and it says greater than or equal to. So we're going to have a bracket here at 5. So this interval is going to go from negative 6 to 5 with a bracket. And then we're going to have a bracket at 5 going to positive infinity. And therefore that is that region. So here's region 1, here's region 2, and there's region 3. Now what we're going to do is we're going to take a testing point for each one. So for region 1, we can pick the value of x, which is equal to negative 7. So if we look at the inequality, x minus 5 over x plus 6, we want to determine if it's greater than or equal to 0. So if we plug in negative 7 for x, we get negative 7 minus 5 over negative 7 plus 6. So we get negative 12 over negative 1, which becomes a positive 12. And is 12 or positive 12 greater than or equal to 0? Well, that is true, so we know it's true in region 1. Now we're going to take a look at region 2. In region 2, we can pick the number 0 in our interval. And then again, we're going to use the same inequality, x minus 5 over x plus 6. We want to see if that's greater than or equal to 0. So we have 0 minus 5 over 0 plus 6. So that gives us negative 5, 6. And is that greater than or equal to 0? Well, that is false, so we know it's false in region number 2. And then in region number 3, we can pick the value of 6. So again, using the inequality, x minus 5 over x plus 6 to see if that's greater than or equal to 0. So we have 6 minus 5 over 6 plus 6. And that gives us 1/12. Well, 1/12 is greater than 0, so we know it's true in region 3. So, where is it true? Well, we can see that it's true in what region? We can see it's true in region 1, so we're going to use this interval. And it's also true in region 3, so we're going to use that interval. So therefore, our result is negative infinity to negative 6, union, negative infinity to negative 6, union, and then bracket 5, infinity.